Good morning, everyone. You can just give me 1 second. I'm just need to open up something here. Oh yeah, I just got my my list up of who's next to present. Okay, so but we do have some administrative issues that we need to discuss before we start. We have one more. Let me get my camera going. I know how much you guys like to sit and look at me for the whole hour, so I'll get my camera started. Oh yeah, there we are. We need to discuss. We have one more test that we have to do. We've essentially covered all the information that we need to cover. So we're looking at now setting the time for the or the date for the last test. What the test is going to have to be done on a Thursday, right? We could potentially do this on Thursday the 9th or the 16th. Any preferences? I think I believe that my environmental topics class have Raz immediately fires out the 16th. Okay, all right. Oh yeah, it looks like the 16th is the date that everyone is looking at. Well, some throwing out the 9th. Okay, I tell you what, let's do it the 16th, right? Once again, this is going to be a fairly tough test because it's worth 30%. But you guys know me by now. I will do whatever I can to help you prepare for this test, and for that reason, maybe potentially the 16th. Is the best time to do that. Okay, so we will do it on the 16th, Thursday, the 16th, and then that'll be you guys done. The other thing I just want to mention is that Amanda Huxter will be with us tomorrow. She's going to be calling in at about 8:30. Tomorrow morning, and she's going to talk to us about energy from waste. Her talk with questions should be about an hour. So in the time from 8:10 to 8:30, we'll probably do a couple of presentations, and then any that are left we will wrap up after her presentation. So I would appreciate it if as many of you as possible could be there for Amanda's presentation. She has taken time out of her, I was going to say busy schedule, but she retired just recently. But she has taken the time to join us. So if you could, if you guys, many as possible, show up for her talk, and if you could enthusiastically ask any questions, I would greatly appreciate it. Okay, so I think that's it from me. Any questions before we go any? Okay. So it looks like everything was just regarding the test. Okay, so according to my list, Aaron is up next. So Aaron, are you good to do your presentation? Okay, so I have to. Okay, so I've allowed you to share. We haven't heard anything from you, Aaron. So I'm not sure. Okay, let's move on to the next person, Aaron. If you could try and resolve that issue, then over the next little while, then we'll just slot you in. Is Alyssa Newhook with us? I don't see Alyssa online. No, Alyssa's not with us. Oh, we're good now. We'll get through this pretty quick here. Claudia, Claudia, you with us? Are you ready
Yes, I
to
am.
present? Okay, perfect.
I am.
Okay, so you should be allowed to share your screen. I give you permission to share.
Okay, so good morning, everyone. The topic I chose to discuss is glass recycling. So glass recycling is the process of turning glass waste into reusable product. Those reusable products are usually mixed with raw materials. So that includes soda ash, limestone, and sand. And reusable products are usually composed of small pieces of glass called cullet. And there are two kinds of cullet. There's an internal cullet, which are defective products found during manufacturing purposes. And there's an external cullet, which are waste glass collected from recycling. So glass recycling is found to be one of the most efficient form of recycling commercial waste because it is very profitable and it helps out the environment. These recycled glass products do not degrade, so they can be reused infinitely. And there is no loss in purity or quality in the final product. So a product that is made from recycled glass has the same qualities as a product that is made from original glass. But not all glass products can be recyclable. So things like light bulbs and window panels, because they have another material mixed with them, they're not able to be thrown out in the blue recycling bins. You'd have to collect those separately. And that is because there's contamination issues. So the materials that they're mixed with might cause some sort of contamination. And that's what we want to avoid. So glass recycling process starts off when you put your recycling bins outside your home for collection. Once the recycled waste is collected, it gets brought back to facilities where it's separated from paper, plastic, and metals. Once you've isolated the glass, then you clean it and purify to get rid of any dirt or contamination. Once the glass waste is clean, then you separate it by color. So you put clear glass with clear glass, you put brown glass with brown glass, and so on and so forth. Then once you're done separating it, it gets crushed into smaller pieces and melted. And then at this point, that's where you introduce the raw materials. And once you have introduced the raw materials, you can shape it and mold it into new products. So some of those recycled products can be glass jars and bottles. There can also be glass countertops, which are made up of 15% cement and 85% recycled glass. And they are more durable than granite countertops. There's also glass backsplash, which is very high in moisture resistance and durability. And then there's also glass asphalt, which is crushed glass mixed with asphalt instead of sand mixed with asphalt. And the reason they do that is mainly for aesthetic purposes because it does sparkle in the sunlight from like the glass glare. So the advantages that come with recycling glass, for every 1 ton of recycled glass, there's energy savings. So you save about 42 kilowatts per hour of energy, or you can convert that into British thermal units, which would be 714,000. And that is because glass made up from scratch requires a very high temperature to be melted at and to produce, whereas cullet melt at a very much lower temperature. 1 ton of recycled glass also saves water and air pollution. So there's 7.5 pounds of air pollutants that are not released into the air and 5 gallons of oil that are not released into the water. There's also CO2 emission that gets reduced by 5% for every 1 ton. And also space in landfills. So obviously when you recycle glass, that space is free and it adds up to be 2 cubic yards. So some facts that I found just worldwide, over 30% of raw material used in glass production comes from recycled products. Switzerland has the best recycling program because 91% of their manufactured glass is recycled. In the UK, glass manufacturers recycle about 70% of their product. In India, 45% of glass waste is recycled every year. Bottles and jar manufacture in South Africa contain 40% of recycled glass. And in the US, 10 to 12% of glass used is recycled, which is very small. These are my references, and I'm done my presentation. Are there any questions?
Okay, thanks for doing that, Claudia. That was very well presented. So I'm going to let any of your classmates ask any questions that they have before I get involved with probably rambling questions. So does anybody have any questions for Claudia? You can either put them in the chat, or you can unmute yourself and ask her the questions. And Curtis has pointed out a very good point. You've set the bar very high for the people that have to follow you today. So it doesn't look like anybody has any questions, but I have a couple of questions, right? My son lives in Chicago, so we go visit him every, 3 or 4 times a year. That was pre-pandemic, but it seems like every place you go in the US, there is a vending machine where you can take your glass containers, primarily bottles, back to, and you feed them into this collection thing, and that you get X amount of cash out of it. So based on that, I'm surprised to see your number that only 10 to 12% of glass in the US is recycled. Do you have any ideas or thoughts, or do you know why their number would be so low?
That I didn't come across in my research, but
Yeah.
It's also like for Canada, there was no percentage because the amount of glass that we recycle is really small. Where like I think I found in 2016, there was a $1.1 million saved through glass recycling. But again, that's not enough to put it in a percentage perspective. So I believe that the US does what they can, but what they are doing adds up to being 10 to 12%.
Yeah, and I guess this is probably more of a comment than a question, but I think beer and wine and liquor bottles, they have deposits on them, so they end up being returned to the to the brewers, I guess, and they get cleaned and reused. But that's not exactly recycling, that's reuse. I do know, going back 20, 25 years ago, when we were really getting into recycling, the contamination issue that you pointed out was a huge issue, in which if they had, just to throw a number out there, if they had 3 tons of glass to be recycled, if there was even just a very minor quantity of green glass in that clear glass that they were recycling, the whole batch could not be used. But it sounds like from your presentation that they've actually developed more uses that might minimize that contamination a bit. So in the glass countertops, I actually didn't know that you could buy glass countertops, but that seems to make sense. And also adding it to Glassvault, as you characterized that ad, that's becoming a lot more prevalent, where they're actually adding glass into asphalt. And I guess, that could be some of the contaminated material that you talked about. So did you ever get any indication that there's any, I mean, I guess all the recycling is occurring in North America. We're not shipping waste glass overseas for recycling. Did you come across that at all, or?
Yeah, so I believe in my research, I came across an article or something that said that we used to send our recycling waste over to China, but they started demanding that we would separate the recycle. So they don't want contamination in their recycling processes. And Canada was kind of like, okay, forget it then. We'll just not ship it overseas.
Yeah, which is probably a good thing, right? Because we're dealing with the the generation at home, right? Yeah. So okay, well, I have nothing else. Thank you very much for doing that, Claudia. You did an excellent job to get us going. And like Curtis said, you set the bar pretty high for those that follow. So you can stop sharing your screen, right?
Okay.
And then, thanks, Claudia.
Thank you.
Okay, Ayush, are you ready to go? Is Ayush with us today? I thought I saw his name. No, it does not look like Ayush joined us. Okay. Okay, Raj. So Raj is up next. So are you ready to present, Raj? I see that you're here. Raj? So we have to keep in mind that if your schedule happens to be today and you're not ready to present, you can do it tomorrow, but you will see a penalty in your marks for having to push it off till tomorrow. So Raj, I'm going to give you one last opportunity to do your presentation. You ready? No. Okay, Aaron, how are you making out with your?
Hello, can you hear me now?
We can hear you now. There you go.
Okay, perfect. Okay, can you see my screen?
You can see your screen. Yes. That's a beautiful shot to start off today.
Yeah, beautifully ugly, maybe. Okay, so chances are that most people here have heard of the oil sand deposits in northern Alberta. And if you don't know what that is, oh, hang on a second, something's not working here. There we go. So if you don't know what that is, the Alberta oil sands are a cluster of deposits around northern Alberta and some of Saskatchewan, totaling over 142,000 square kilometers of surface area and subsurface deposits of oil sand. Oil sand is a combination of crude tar-like bitumen, wholly embedded with quartz sand and clay, and a layer of water surrounding each grain of sand due to the hydrophobicity of the petroleum hydrocarbon. So if you were to pick up a handful of oil sand, it would feel like you're holding a clump of sandy peanut butter. Surface mining bitumen ore is a messy process that turns a landscape into an absolute wasteland. Bulldozers and excavators scour the surface, delivering thousands of tons of bitumen ore per hour to processing facilities. The bitumen is extracted using a hot slurry of water and solvents, which is then separated by density, with the lowest quality material being deposited in large tailing ponds, as you can see the process in the images to the right. So in general mining terms, tailings are the leftover materials and sludges after the target mineral has been extracted. The bulk of the discarded bitumen material is sand and water and can contain, according to the NGO Environmental Defense in 2017, naphthenic and paraffinic solvents, benzene, and other polyaromatic hydrocarbons, heavy metals such as lead, arsenic, and mercury. So this toxic soup is then ejected into tailing ponds, where it stays for as long as it takes to settle out as much as the fine particulates as possible. Fine particulates are anything that are under 44 microns in diameter. Meanwhile, birds and other wildlife are free to drink from these highly contaminated ponds, despite using scarecrows and loud sounds like shotgun blasts to scare them off. Huge risks are undertaken due to how easily an unnoticed leak could occur, affecting many thousands of square kilometers of ground and surface water, such as the nearby Athabasca River and any communities downstream. Speaking of water, bitumen extraction requires a lot of it, about 9 barrels of water per 1 barrel of bitumen. Almost all mining companies will reclaim their tailing water with variable efficiency and recycle that back through their extraction process. However, a portion of fresh water is still required to keep up with losses. The Athabasca River is the primary source of this necessary water replenishment, to the tune of 3 barrels of fresh water for every 1 barrel of bitumen produced. So you might be wondering now, how much contaminated water are we talking about here? Well, according to the Tailings Management Framework for the Mineable Athabasca Oil Sands, aka the TMF, in 2013, there was an estimated total of 1 trillion liters of contaminated process water stored in tailing ponds. That's 1 cubic kilometer of wastewater, which is visualized here compared to Lower Manhattan. So fun fact, it would take Niagara Falls roughly 1 year to fill this volume. As of today, Environmental Defense estimates approximately 1.7 trillion liters, or 1.7 kilometers cubed, of process-affected water. That is an increase of about 7.3 million liters per month over the last 8 years. So there are several levels of legislation that govern the tailings in Alberta. The top level is Oil Sands Conservation Act, as well as the Environmental Protection and Enhancement Act. And under those, we find the Directive 85, the Fluid Tailings Management, and finally, the Tailings Management Framework, or the TMF. According to the TMF, former tailing ponds must be ready for reclamation no later than 10 years after the storage pond was in use, which is typically when the mine is depleted and shuts down. This gives the mining company 10 years to remediate their process-affected water and land. Eventually, the remediated water will be reintroduced back into the watershed, and if the reclaimed land passes the reclamation certification process, the land will belong to the citizens of Alberta once again. Neither Directive 85 nor the TMF outline any proven remediation methods, so it's left to the oil corporations to decide how to proceed. Within the last couple of years, scholars at the University of Alberta have repurposed a remediation strategy used by large pharmaceutical labs and consists of in situ oxidation using ozone to break down the naphthenic acids, which is then run through a biofiltration system where microorganisms can consume reduced organics. Other proven methods include more mechanical efforts, such as in the case of Suncor Energy's Pond 1, now known as Wapisiw Lookout, where the fine tailings were pumped out for ex situ treatment, and the original topsoil was replaced into the former pond site. It's a very effective method, but also very expensive and labor intense. So you can see the tailings pond before the reclamation on the top right, and then a few years later, that's what it looks like. Okay, some final thoughts. First, surface mining bitumen is extremely messy and ugly process that I think extracting more fossil fuels in today's world should be maybe reevaluated so that we can move towards becoming more swiftly a carbon neutral economy. Secondly, the Alberta government needs to establish more strict regulations instead of loose, thoroughly lobbied frameworks and directives that are largely ineffective at enforcement and leaves most of the decision-making to mining corporations. Finally, and perhaps the most disturbing, to me at least, is that it's extremely difficult to find any accessible reports or papers discussing the chemical analyses of bitumen tailings, groundwater reports, things like that. I also encountered a lot of propaganda from both sides of the fence, with some environmental NGOs intentionally being misleading, not backing up some of their claims with sources. And of course, what seems like big oil funding small news websites to paint their corporate agendas in positive light. Only one thing is for sure, though, is that there's an incredible amount of money and people's livelihoods at stake. Personally, I'd rather err on the side of caution and nature. So thank you for listening. All done.
Thanks, Aaron. That was also very well done. Does anyone in the class have any questions? It doesn't look like there's any. Apparently, Matthew,
Thanks,
like
Matt.
your handmade art. I guess see Matthew's used to he's used to looking at my my poor excuse of doing drawings in our topics lecture. But so I do have a couple of questions, right?
Sure.
So you looked at the the water usage to recover the bitumen from the essentially the sands, right? Did you look at the other energy uses? So like the amount of natural gas that needs to be used to process the material?
No, I didn't look into the process that in depth. I tried to focus more on the immediate issue of the fact that there was, so much water, so much tailings water existing, and its presence essentially.
Yeah. So an interesting fact, and you could Google this if you wanted to. Way back at the very, very early 1900s, there was someone from Imperial Oil in the U.S. Who was moving through that area looking for reservoirs of oil that could be recovered, and they did actually identify the tar sands, but their recommendation at the time was this material will never come out of the ground because there is not an efficient way of recovering the oil. But as we can see, as technology advanced, they did come up with the technological methods to extract this material. And like you said, it's not pretty, right? It's a very disruptive process. I was lucky enough that I worked for Suncor. And Suncor was one of the original partners in the oil sands. So I did actually get to see the oil sands. But I noticed in your references there that you made, there's a reference there that refers to diluent, right? That's another very large issue with tar sands oil. So once it's being produced, produced, it's still too thick to move through pipelines.
Yep.
Right, so it has to be diluted by other using solvents to get it into you know, a flowable form so it can go through pipelines. And
Yep.
one of the, if I don't know if any of you remember the big train derailment and explosion in Quebec, in which I can't remember the name of the town now, but essentially the downtown was incinerated, and I believe about 50 people died. If I'm not mistaken, that explosion was a result of tar sands oil mixed with the dilutant, and the dilutant made the oil significantly more volatile inside the rail cars than they anticipated it would be. So yeah, I mean, there are many issues surrounding this, and you did a good job of kind of trying to condense that down into 5 minutes. So
Yeah,
thanks
I
for
could
doing that.
probably have gone on for about an hour.
Yeah, and like you say, one of the big issues surrounding this is you know, you have you know, on the one side all kinds of misinformation being put out there against the oil sands. On the other side, you know, there's all kinds of misinformation to support the oil sands, and to try and walk that tightrope down the middle is a tough thing to do. But I think you did a fairly good job of you know, just laying it out as it is, right?
Okay, thank you.
Apparently, the Alberta government have a war room in which they monitor environmental groups, and they will try to, when an environmental group comes out with something, they will try to get something out there to discredit whatever is being put out there. So you better hope none of your classmates provide your presentation to the war room, or you may end up on the on their list of people that they need to discredit. So thanks for doing that, Aaron. It was
Okay, thank you very
well
much.
done. Now I believe that Raj is now ready to go. Is that right, Raj? Okay, so we can now hear you, Raj.
Yeah. Can I see my slides? Yeah.
Nope, we can't see your slides. So down on the bottom, you should have, if you put your mouse down by the bottom, you should see a box that says share screen.
Yeah, that's the problem, that I'm unable to share it.
What's your issue? You can't find the share screen button, or?
No. I'm unable to share what is happening. It is not showing any option to share.
For those of you that have presented already, are you able to help Raj as to how he can find? All I can do is see on mine where how I would share my screen. Is it potentially different for you guys?
For me, it's just a green button at the bottom. You just press that, and then it gives you the option to share what screen. So you can just choose the PowerPoint that you're going to be presenting from.
Okay, so move your mouse right down to the bottom. And almost go
Yeah,
right
I
off.
moved it and it's not showing any option. I think I should left out, then I again need to join the meeting.
Okay,
Only
well,
thing.
so we'll move ahead of you. So you try and figure out your technical issues, right? Okay, and we're going to go to Ria. Are you ready to go, Ria? I'm not even sure if oh, Ria is on. So are you ready to give it a try, Ria?
Oh, yeah.
Okay.
Can you see my screens now?
It says you've start. Yep, you can see it. We can see it now.
Oh, you're seeing it or not?
Yep, we see it. Yep, we can see
Okay.
your PowerPoint. Yeah, so you're on your last screen. Okay.
Okay. So, hi guys. Today's topic is like sustainable innovation to convert plastic into an opportunity. This is a random picture I got from the internet, and this is showing something plastic and the West in the sea, and there is a little quote written over here. It's showing just because you can't see it, it doesn't mean it isn't here. So I'm taking it into the other manner that just because we are surrounded by this so much plastic waste, it doesn't mean that there is no method that we can reuse it. And in today's topic, I'm gonna go with that. So just the fact that more than 300 million tons of plastics is produced every year, on which only 10% is recycled. 8 million tons end up in our oceans, with a large majority of it originating in Asia and the USA. So if we talk about the Canada, every year Canadians discard 3 million tons of plastic garbage, of which only 9% is recycled, which means the great majority of the plastic end up in the landfills, and the roughly 29,000 tons find its way into the environment. So these are just pictures that how plastic waste affect the animals. And for the plastic waste management, I'm going to use the concept the reuse, reduce, and the recycle, the 3R rule. So what's the plastic? Plastic is a material which contains one or more organic polymer of larger molar mass, solid in finished states, and some stage by manufacturing into the finished article can be shaped by its flow, which is called plastic. Plastics are the wide range of the synthetic or semi-synthetic materials which used polymers as the main ingredients. So we are going to discuss about the two types of plastics. The first is a thermoplastic. Thermoplastic are a kind of plastic that can be modified if we give them the enough amount of heat, while the thermostatic plastics can be modified if we give them the highest amount of heat. So the types of plastic products that we are used on the regular basis, that are the plastic bags, coatings, furnitures, sheets, fittings, tanks, toys, buckets, sanitary ware, and the stationery. So the plastic are durable and inexpensive. As a result, levels of plastic production by the humans are high. However, the chemical structure of the most plastic renders them to resist to many natural processes of degradation, and as a result, they are slow to degrade. Some of them are non-degradable as well. Together, these two factors have led to the high performance prominence of the plastic pollution in the environment, and millions of animals are killed by plastics every year. For instance, Henderson Island. Henderson Island is covered in more plastic trash than anywhere else in the globe. The island contains approximately 671 pieces of plastic trash per square foot, and that is no one has actually hauled the garbage there. So there are many ways that we can reduce the plastic pollution by converting waste plastic into the useful resources. For instance, plastic roads converting plastic into the fuel, and the house constructions with the plastic bottles. Let's take a look about the plastic roads. So what are the plastic roads? Plastic roads are the roads that are made of completely of plastics or composite of plastics made with other materials. Difference between the plastic road and the standard road is that the standard roads are made entirely of asphalt concrete, which consists of mineral aggregate and asphalt. whereas plastic roads are made up of composite of plastic. Use of innovative technology not only strengthen the road construction, but also increase the road life, as well as it is environmental friendly and creating a source of income as well. Let's say in India, there is an extreme humid climate where the temperature reaches over 50 degrees Celsius in the summer and torrential. And then in the monsoon, there is a highest amount of rain been there. So the rain create havoc and leaving the most of the roads with the big potholes. In such situation, we can create the strong, durable, and eco-friendly roads which will relieve the earth from the plastic waste. What's the characteristic of the waste plastic? So plastic is a good binder. It improves the aggregate impact value. It helps to improve the quality of flexible pavement. Plastic will increase the melting point of the bitumen, and that's the biggest plus point that we are going to use when we are going to construct the road. This is just the picture of bituminous pavement, which is in India, that is West India constructed the road using plastic, waste plastic. So what's the basic process? So the process contains segregation, cleaning process, shredding, and the collecting process. So this is the actual process which is used in the construction of the polymer coated bitumen road. So what happened in this process? In the first process, the plastic waste gets collected. So in that collection, the thermoplastic and the thermo got differentiated, then the thermosetting plastic. Then this plastic goes in the cleaning and drying process where the plastic got washed and then get dry. This plastic, clean and dry plastic waste got in the shredding machine, and at that, in that, the shredding plastic, the shredded plastic got the size of 2 millimeter to the 4 millimeter. This shredded plastic got aside, and another shredded polymer waste, the 5 to 10% percentage weight by weight is added to the heated stone aggregate. So the aggregate got heated for 30 to 40 seconds and mixed with this shredded plastic waste to 160 degrees Celsius to 170 degrees Celsius. And then this material got mixed into the bitumen, the hot bitumen, at the temperature from 155 degrees Celsius to 163 degrees Celsius. And this material, this mixture is called waste plastic aggregate bitumen mixture, got used for the construction of the plastic road. This is the basic steps which I showed you. Okay, so there are two basic process or field trials we can say. First is the dry process. So what happened in the dry process? The aggregate got heated at 170 degrees Celsius in mini hot mix plant. And then this shredded plastic, they both from the equal proportion got mixed with the bitumen. And then it is used for the road. While in the wet process, the waste plastic directly got mixed with the hot bitumen at the 160 degrees Celsius temperature. And then that mechanical stir that takes place. And then some stabilizer got added and some proper cooling is required. So basically the wet process takes more time and it requires a lot of investment and the bigger plans. That is why the wet process is not commonly used and the dry process is most useful. So after constructing the road, we can compare the both roads. So these are the plastic roads, these are the bitumen roads. In the plastic road, we cannot find the potholes, no cracking, no deformation, and no edge flow, which we can find in the bitumen road without plastic after making him face some situations. What is the advantages of waste plastics bituminous mixture? So we can get stronger roads with increased stability value, better resistant towards rainwater and the water stagnation, no stripping, no potholes, as we said earlier, increased binding and better bonding of the mixture, reduction in pores in aggregate, and hence less rutting and less traveling, no leaching of plastic, the strength of the road increased by 100%. No need of maintenance of the roads. Disposal of waste plastic would be less problematic with this way. So if we look at the data, for 1 kilometer by 3.75 meter road, 1 ton of plastic is used, which is equals to approximately 1 million carry bags. And due to this, 1 ton of bitumen is saved. And by doing this, we can save the cost of road construction. The use of waste plastic on the road would help us provide better place to burying the plastic waste without causing any disposal problem. Let's move on to the next topic. Another use we can use for the waste plastic is we can make thermofuel from the waste plastic using plastic pyrolysis method. Recycled plastic and the plastic waste to all can be defined as a technology that is used to convert non-recycled plastic into synthetic crude oil. Plastic pyrolysis is a very effective process and very known method as well, in which plastic is exposed to high temperature, but in oxygen-free environment. What does pyrolysis means? Pyro means heat and lysis means breakdown. At any temperature, the molecule is in vibrating state is called molecular vibration. The frequency at which molecule vibrates is directly proportional to the temperature of the molecule. During pyrolysis, the molecule are subjected to very high temperature, leading at very high molecular vibration. And at this stage, every molecule gets stretched and shaken to such an extent that molecules start breaking down into smaller molecule. And that's called pyrolysis, plastic pyrolysis. As we all know that the plastic is hard to break down, and that's why we add some catalyst to help to break some chemical bonds. And as a catalyst, we use zeolite and ZSM5. There are so many other catalysts as well, but these two are most used ones. So what's the actual process takes place in this method? So the waste plastic goes to the pre-treatment method first, then it gets shredded, goes with the pyrolysis method, condensation, and the refining. This is the whole process takes place in the laboratory or the big project. Let's take a look one by one. So waste plastic get collected and then first go to the pre-treatment process at which removals of any foreign matter takes place. Then it sent to the plastic shredder, and the plastic shredder is the machine at which the plastic cuts into the smaller pieces. Then this plastic pieces goes into this, which is called densifier. And this densifier, what do the densifier? That this densifier compress the smaller pieces into the dense material to facilitate the easier storage or easier handling. Then this goes to the chamber, which is called pyrolysis chamber, at which pyrolysis takes place. So in this chamber, plastic is heated up to 450 degrees Celsius in the presence of catalyst and in the absence of oxygen. And in the absence of oxygen, it slowly melts and converted into gaseous state. And then this gas sent into the condenser. In the condenser, condensation takes place. What is condensation? So condensation is a conversion of the vapor or gas into the liquid. And this liquid then collected inside the chamber, and then it goes for the further refining. So at the refining process, this is just a simple flow chart. Whatever I discussed here, it is here. These are the same. So after refining, we can get 80% of oil, 15% of gas, and 5% of carbon black. So that 80% of oil can be used in refinery, in the industries, in generator. Also, it can replace the petrol. So back in India, in the West India, some mechanical students, some engineering students did this process and find the data that 1 liter of plastic waste oil, they put that oil in the Bajaj bikes. That's these bikes. So when they run that bike gives then average 4 kilometer more than we get by using regular petrol. The 50% gas, that 50% gas can be used to heat the reactor instead of using coal, wood, or any other oil. And this 5% carbon black is used as a slug for the construction or as a replacement to the coal. As we said, the data that around 1,000 kilograms of recycled plastic saves the 685 gallons of oil, nearly 5,800 kilowatt of electricity, and more than 30 cubic yards of the landfill space. This is the oil that we get after doing that process from the plastic waste. So from millions of tons of plastic, we can get the oil. This is a picture of Mr. Rajagopalan Vasudevan. He is an Indian scientist, and he invented, or he found that process of plastic roads in India, and that's why he is known as the plastic man of India. These are the roads made from the plastics. This is the process, and that's all. These are the references. Thank you.
Sorry, I muted myself because I was coughing earlier. Yeah, so I had said thanks, Ria. That was very well done and brought an interesting perspective to our course. It was nice to see the international perspective there. Does anyone have any questions for Ria? Doesn't look like it. Do you have any information? Has this process ever been used in North America, Ria, that you know of?
This process is used in India. I can show you some YouTube videos, but I'm not sure that this process is used in another country or not, because I had some information for this process as plastic road when I was doing my bachelor's in India, and that's why I got this point that I can take this as my presentation topic. But if you want to see a YouTube video, I can show you.
Yeah,
Do you want to
yeah,
see
no,
it?
as I say, so it was give us a good international perspective, and it's a use of plastic that I had no knowledge could be done. So thanks for doing this. And the issue of plastic waste is a huge issue. You did go longer than 5 minutes, which probably saved Raj's bacon for today. But Raj, can you try and resolve your issues with sharing your screen and be ready to present at 8:10 tomorrow morning? Okay. Ria, can you stop sharing your screen? Perfect. Thank you. Any questions before you go? Yeah, Aaron actually just raised a good point. He'd like to know if plastic impregnated roads would help mitigate potholes after freezing thawing in Canadian climates. And you would have to think, I mean, with a little bit of information I have on it, that it would certainly be worth looking into, because it seems like the use of plastic in asphalt adds a bit of flexibility to it. So it could maybe a potential benefit there. Okay, all right. Thank you very much for all of you who presented today. It was quite enjoyable sitting here watching them. And I will see you at 8:10 tomorrow morning. So Raj, if you can try and get your issues resolved and be ready to go at 8:10 tomorrow morning. Okay, all right. Thank you very much, folks. Bye-bye.